Assalamu alaikum YouTubers, myself SLK and I'm here with a new lecture presenting the design of rectangular open channel or the determination of the most economical section of a rectangular open channel. And the topic may goes to hydraulics. The most economical section is a section having maximum discharge with minimum gross cross-sectional area. Remember, our approach is only the rectangular open channel. So for rectangular open channel, we have just only two terms to be a most economical section. The breadth of the most economical section will be just 2 times of its depth. Remember, this is only for rectangular open channel. And the hydraulic mean depth will be just the half of the depth. Actually, the hydraulic mean depth is just the gross cross-sectional area divided by the weighted parameter of the given section. But over here, we just assume for the most economical section is the half of the depth. Let's see how we determine the most economical section for rectangular open channel. Say, if we are asked to determine the most economical section for rectangular channel to carry 0.3 cubic meter per second is the water discharge, and the bed slope is just 1 in 1000. The Chezy constant is also given as C equals 6O. If you see in the example terms, the Chezy constant is given, it means we can use, of course, the Chezy's formula for this approach. And the Chezy's formula is given in this form. The discharge equals as C square root of Mi. Here Q is just the water discharge, as the gross cross-sectional area of the channel, C is just Chezy's constant, M represent the hydraulic mean depth, or just D by 2 for the most economical section. I is just the bed slope of the channel, or just the gradient. If you see, everything is given, so we need some plug-in chug-ins, like the Q is given, which is 0.3 cubic meter per second, or just 0.3 cubic. So I'll just plug this value over here in this equation, which is the Chezy's formula. 0.3 equals the gross cross-sectional area. Remember, the gross cross-section area will be just the B times the depth, because this is just a rectangular channel. Remember, for the most economical section, the breadth must be equal to 2 times of its depth. So A equals 2 times D times D. Or I can shortly say the gross cross-sectional area equals 2 times of D square. Now I can put the gross cross-sectional area in the Chezy's formula. So 0.3 equals 2 times D square. The constant is given as 6D. Square root of the hydraulic mean depth. Remember, the hydraulic mean depth will be just the half of the depth, because this is a nice term for the most economical section. So square root of half of the depth times I. I is just the gradient or the bed slope, which is given as 1 in 1000. I can also write this guy in fraction form like 1 over 1000. Let's do some maths, like discharge equals 2 times 6D will be just 120, so 120 D square. We can multiply the depth or the D with the 1 and 2 times 1000. So we can get, of course, the square root of D divided by 2000. And this is, of course, a simple maths, alright? Just simplify the same little more, of course, we can get D power pi by 2 equals 0.1118 blah 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 blah. Here I don't need the power as pi by 2, so I'll just multiply the power with 2 by 5. And remember, changes to one side must be applied to another side of the equation. So I can put 2 by 5 to another side of the equation as in form of power. Pi will bam and 2 will bam. Of course, we can get the depth or D equals 0.416 meter or 41.6 centimeter. If you remember, in the most economical section, the breadth must be equal to 2 times of its depth. So the breadth B equals 2D. I can just plug the depth value over here in this equation. We can get, of course, B equals 2 times the depth is just 0.416 meter. So we can get the breadth equals 83.2 centimeter or 0.832 meter. And here is our result in the most economical section, like the breadth equals 83.2 centimeter and the depth equals 41.6 cm. And this is the most economical section. Of course, we have determined it. Next time we'll try to bring a new lecture for determination of the most economical section of a trapezoidal channel. Thank you guys for watching. See you next time.